Good day, everyone. I am Divan Montes from Bachelor of Secondary Education, major in Mathematics, second year, Section A. In this moment, we will talk about Euclid's Elements from Book 13, Proposition 6. Are you now ready for today's discussion? Okay, then let's start. From Euclid's Elements, Book 13, Proposition 6, it states that if a rational straight line is cut in extreme and mean ratio, then each of the segments is the irrational straight line called apotome. We have here a line, and we will demonstrate what the proposition means. Let line AB be a rational straight line cut in extreme and mean ratio at C, and let line AC be the greater segment. Look at the line AB. Let's assume that this is the original line and will be cut into two line segments. Now, we have the longer line, which is the line AC, and the shorter line CB. And based on the proposition 6, we can say that each of the straight line AC and CB is the irrational straight line called apotome. In line AB, we add the line DA with a measure of half the line AB. And if the original line AB is rational, therefore, half the measure of it, which is the line DA, is also rational. Recently, we always talk about or we always mention the word apotome. So, what is an apotome? In mathematics, apotome is a line segment formed from a longer line segment by breaking it into two parts, just like what we had talked lately about the example. It is also the difference between two quantities commensurable only in power to the whole. The other part is the apotome. When we say commensurable or proportional, it means they are having a common measure. Based on the first proposition on Euclid's Elements, Book 12, the square on CD is 5 times the square on DA. So we have here the square on DA and the square CD. Therefore, the square of DA is commensurable to the square of CD. But among the lines in the said proportions, only the squares of DA and the square of CD is commensurable, not their lines. So those squares includes the line DA and the line CD. We can say that line DA is rational, and it is half the measure of the rational line AB. So among the mentioned two lines, therefore, only the line AC is irrational and is called an apotome. Next, based on the previous proposition, since AB is cut in extreme and mean ratio, and AC is the greater segment, therefore, the rectangle AB by BC is equal to the square AC. Then, if the square AC is equal to the rectangle AB by BC, therefore, if the square AC is an apotome, so is the rectangle AB by BC. Yes, they are both an apotome. But take note that the sides of the said rectangle consist of two lines, which are the lines AB and line BC. And remember that the line AB, the original line, is rational and not an apotome. Therefore, on the rectangle AB by BC, only the line BC is irrational and is called an apotome. To sum it all up, the lines AC and BC, which are the line segments formed when we break the original line AB, is an apotome. Thus, we can say that if a rational straight line is cut in extreme and mean ratio, then each of the segments is the rational straight line, called apotome. And that's it for today's discussion. I hope that you learned something today. Thank you for listening. Stay safe and God bless.